In this question, you can see that there is an electrical dipole and the charges plus q and minus q are located in the xy plane at the coordinates shown. This one is plus q and this one is minus q. And the electric potential at this point is V0. Now the charges are moved at these 2 points, and we have to find out the electric potential at point P due to the new dipole. So this is a simple question, and you can see that the potential due to dipole is Kp cos theta by r cube. Now you can see that this distance r is 100 root 2. This is 100 root 2, and this angle is 45 degree. So V0 is K P, and P initially is Q into this distance, and this distance is 4 mm. So K Q into 4 cos 45 by r cube. Now when we have rotated the dipole by some angle, in fact we have shifted the dipole. So by shifting the dipole to the new position, the r remains same but angle changes. Now this angle is 45, and let's suppose that this angle is alpha. So the new length of this line, you can see that the length of this half line is root 5, and this is root 5, and this is r square. Okay, so this is root 5 and this is root 5. So this total length is 2 root 5. Okay, so now the potential at the same point due to the new dipole is K, Q is same, and the total length is 2 root 5, and the angle is cos alpha plus 45 divided by r square. Now r is same in both the cases, so V by V0 will be equal to this is 2 root 5 cos alpha plus 45 divided by 4 into cos 45, which is 2 root 2. Now this alpha, you can see that tan alpha from that triangle, from this triangle tan alpha will be equal to, this is 1 and this is 2, 1 by 2, and therefore cos alpha is equal to 2 by root 5, and sin alpha is equal to 1 by root 5. So V by V0 is equal to root of 5 by 2, and this cos A cos B minus sin A sin B, so 1 by root 2 into cos alpha minus sin alpha. Okay, so this is root 5 by 2, and cos alpha is 2 by root 5, and this is 1 by root 5, so it would be 1 by 2. So V is equal to V0 by 2. So the correct answer is B. Now we move on the next question. In this question, you can see that the Young's modulus is expressed in terms of C, H and G, where C is the speed of light, H is Planck's constant, and G is universal gravitational constant. We have to choose the correct option. Okay, so we know that Young's modulus is dimensionally equal to pressure, and pressure is M1 L minus 1 T minus 2. We know that H is equal to E by C. Okay, so the dimensions of H would be M1 L2 T minus 2 divided by L1 T minus 1. So you can see that it is M1 L1 T minus 1. Now the dimension of G, which is universal gravitational constant, G is F r square by M1 M2. So F is M1 L 1 t minus 2 into r square is L2 divided by m square. So G is m minus 1 L cube t minus 2. Now we know that gamma is equal to c to the power alpha, h to the power beta and g to the power gamma. So the dimensions of gamma are m1 L1, m1 L minus 1, t minus 2, and dimensions of c are L1 t minus 1. Dimension of h are m1 L1 t minus 1, and dimension of g are m minus 1 L3 t minus 2. Now m1 L minus 1 t minus 2 is equal to m to the power beta minus gamma, L to the power alpha plus beta plus 3 gamma, and t to the power minus alpha minus beta minus 2 gamma. So you can see that after comparing, beta minus gamma is minus, in fact, plus 1. Okay, and alpha plus beta minus 3 gamma is minus 1, and alpha plus beta plus 2 gamma is minus 2. So by solving these three equations, the correct answer would be option A. Now we move on the next question. In this question, a particle of mass m is moving in a xy plane, and in this plane its velocity is given by this one. Okay, where alpha is a non-zero constant. So we have to find out the force acting on the particle. First of all, let us see that v, velocity, is equal to alpha y I cap plus 2 x j cap. And the acceleration, you can see that in this equation vx is alpha y and vy is alpha into 2x, 2 alpha x. So you can differentiate this equation dv by dt, and dv by dt will be alpha dy by dt I cap plus 2 alpha dx by dt j cap. So A would be equal to alpha vy I cap plus 2 alpha vx j cap. Now we can substitute the values of vx and vy. So A would be equal to 2 alpha square x I cap, and B would be equal to 2 alpha square y j cap. So the force will be equal to ma, and F will be equal to 2 alpha square m x I cap plus y j cap. So the correct answer is A. Now we move on the next question. In this question, an ideal gas is in thermodynamical equilibrium and the number of degree of freedom of the molecule of the gas is n. If the internal energy of 1 mole of the gas is un and the speed of sound in the gas is vn, then at a fixed temperature and pressure, which of the following option is correct? So you know that the speed of sound in the gas is under root gamma RT by m, and gamma is Cp by Cv, and the value of gamma in degree of freedom is 1 plus 2 by f, which means that gamma is inversely proportional to f. So gamma of obviously 5 degree of freedom would be less than gamma of 7 would be greater than. In fact, we can conclude that gamma is inversely proportional to f. Now we know that velocity is also directly proportional to gamma. So gamma is inversely proportional to f, so velocity is inversely proportional to f. So velocity of the higher degree of freedom would be lower. So option A, B and D are incorrect, and therefore the correct option is only option C. You need not to check the internal energy, and if in case you want to check the internal energy, then you can write down the internal energy as NFRT by 2. So use directly proportional to F. Now we move on the next question. In this question, you can see that there is a monochromatic light wave which is incident normally on this glass slab. The thickness of the slab is D, and the refractive index of the slab increases linearly from N1 to N2 as we go up. So we have to find out that which of the option is correct. You can see that when these light waves will enter this slab, they would take different times to cross the slab because they are entering the region which has different refractive index at both ends. So when this light will enter this region and this will enter this region, let's suppose this is 2 and this is 1. So if N2 is greater than N1, so the speed of this wave in medium 2 would be less than the speed of wave in medium 1. So the wave which is in 1 would take lesser time to cross the slab, and hence it would emerge out and it would travel some distance at the time when it will emerge out. So we can say that this point and this point somewhere here are the points which are in same phase. So you can see that this should be the path difference, and the path difference delta x should be equal to the difference of optical path lengths. So the difference of optical path lengths will be N2D minus N1D. So delta x is N2D minus N1D. And therefore, we can say that this point A and A dash would be the points which have the same phase difference. In fact, same phase. So the wave front of this wave would be like that now. And due to the fact that the angle of emergence of these waves would be same, they would emerge out at the same angle, it would also emerge out at the same angle, but just at this point it would have many points on this wavefront which would emitting the light in all the directions. So some of the light waves which is having the plane wavefront would go like that. So the deviation we can say that is theta, and tan theta would be equal to N2 minus N1 into D by H. Okay, so one of the correct option is B, and the option D, which says that deflection angle depends on N2 minus N1 and not on the individual values of N1 and N2. This is also correct because we can say that this deflection depends only on the difference of N2 and N1, not on individually N1 and N2. So the correct answer is B and D. Now we move on the next question. This is a annular disk of mass m, and its inner radius is A and outer radius is B. It is placed on a horizontal surface of coefficient of friction mu as shown in the figure, and at some time the impulse of J is equal to J naught I cap is applied at a point which is at a height of h above the center line of the disk. If it is given that h is equal to hm, at which the disk rolls without slipping on the x-axis, then which of the following options is (r) correct? So the first option, that for mu is non-zero, A is 0 hm is equal to v by 2. So let us examine this fact. Let us first of all write down the equations of momentum and angular momentum. So we know that the impulse is equal to change in momentum, and initial momentum was 0. Then therefore the final momentum is mv com. So v com is j naught by m, and the angular impulse is j naught into h, which is equal to I omega. So omega will be equal to j naught h by I. Okay, so for pure rolling, it is necessary that v com should be equal to r omega, where r would be this one, b. Okay, so because contact point should remain at rest, so b into omega is j naught h by I, and v com is j naught by m, and that is b j naught h by I. So I should be equal to mbh. Now let us see that what is I. Now you can see that if a tends to 0, then this is almost a ring. Okay, because it is almost hollow. So for a ring, the moment of inertia is m r square, and r would be b. So you can see that if I is equal to mb square, then h would be equal to b. In fact, now if a tends to 0, then this would be a solid disk of radius b. So I disk would be mb square by 2. So mb square by 2 will be equal to mbh, and h would be equal to v by 2. So the correct option will be A. Now to check B option, if A tends to B, and if A tends to B, then this would be a ring, and I ring would be mb square. So you can substitute the value mb square in this equation, this one, and it would be equal to mbh. So h would be equal to b. So option B is also correct. Now for h is equal to hm, the initial angular velocity does not depend on the inner radius. You can see that for pure rolling, because when h is equal to hm, then the disk is rolling purely, it is given in the question. So if in option C it is given that h is equal to hm, then we will assume that disk will be in the state of pure rolling by default, and therefore omega will be equal to v com by the outer radius, which is b, and v com v naught would be j naught by m. So it is not depending upon the inner radius. So option C is also correct, and option D, that if mu is equal to 0, h is equal to 0, wheel always slides without rolling. See, if mu is 0, there is no friction, and h is 0, then this j naught is acting on the central line. So the angular momentum of the wheel would be 0, and therefore omega would be 0, but v com would be in the positive x direction, which means that this disk will slide on this ground without any omega. So this would be also correct. So the correct answers are A, B, C, D. Now we move on the next question. In this question, there is a electric field associated with the electromagnetic wave propagating in a dielectric medium, and the electric field is given by this equation. So we have to find out that which of the following option is correct. So first of all, you can see that electric field is in this plane. So let us draw the electric field. This is x and this is y. So electric field is like that, and this angle is theta, where tan theta is 1 by 2. The value of electric field, the peak value, is 30 root 5, and we have to find out the equation of magnetic field first of all. So you can see that magnetic field are always perpendicular to the electric field. So this would be 90, and this angle would be equal to 90 minus theta. So this angle would be equal to theta. Okay, so this is the magnetic field. Now we can say that the speed v of the wave in this medium is, you can see that speed is this upon this. Okay, in fact this upon this. So 5 into 10 raised to power 14 this is frequency, and divided by 10 raised to power 7 into k. This is wave number. So this is the speed, and it is 3 by 2 into 10 raised to power 8 meters per second. Okay, so this is the speed, and therefore we can say that the speed of light is 3 into 10 raised to power 8. So, and mu is equal to c by v. So mu is equal to 2. So the one of the correct option is D. Now the other thing, that what is the magnitude of magnetic field? We know that E upon B is equal to V, and E is 30 root 5, and B, this is V is 2 into 3 by 2, in fact, into 10 raised to power 8. So this is 10. So B is equal to 20 root 5 into 10 raised to power minus 8. So B is equal to 2 root 5 into 10 raised to power minus 7. So Bx will be equal to B cos theta with a negative sign, because Bx is pointing towards backward direction. B sin theta, in fact. So the value of sin theta, if tan theta is half, then sin theta is 1 by root 5. So Bx will be equal to 2 root 5 into 10 raised to power minus 7 into 1 by root 5. So Bx is equal to 2 into 10 raised to power minus 7. So one of the correct option is A. And By is equal to B cos theta, and cos theta is 2 upon root 5. So it would be 4 into 10 raised to power minus 7. So this is wrong. And wave is polarized in xy plane with polarizing angle 30 degree with respect to x-axis. This is also wrong, because this angle is not 30 degree. Neither this angle is 30 degree. So the correct answers are only A and D. Now we move on the next question. In this question, you can see that there is a thin circular coil of mass 5 gram and radius 4 by 3. This coin is initially in horizontal xy plane, and this coin is tossed up vertically in z direction by applying an impulse of this magnitude. The distance at which impulse is applied is 2 by 3 centimeter from the center, and coin spins about the diameter and moves along the z-axis. So we have to find out that by the time in which coin will return to the initial position, how many rotations has it completed. So first of all, let us see the situation that that impulse which we have applied will be equal to m VCOM, and VCOM will be equal to J by M. Okay, so this is the velocity of center of mass, and with this velocity it would take a total of 2 VCOM by G time. So it would be 2 J by mg. This much time it would take to come to the ground at the same initial position. Now, in the next case, let us see that the angular effect of this impulse would be J into r by 2. You can see that this distance, this radius r is 4 by 3, and the point where impulse is applied is at a distance equal to r by 2. So J into r by 2 will be equal to the change in angular momentum, and when we will apply the impulse, then due to the angular effect, this disk will rotate about this axis, which is passing through the diameter in the plane. Therefore, about this axis, the moment of inertia of the disk is mr square by 4, and omega is the angular velocity of the disk about this axis. Now let us see that omega will be 2j by mr. Now we know that theta is equal to omega t, and theta will be omega, which is 2j by mr, and time is 2j by mg. Okay, so theta is 4j square by m square gr. So theta will be equal to 4, j square will be pi by 2 into 10 raised to power minus 4, m square will be 5 into 10 raised to power minus 3 whole square, g will be 10, and r will be 4 by 3 into 10 raised to power minus 2. So this theta would be 60 pi, and we have to find out the number of rotations. So 60 pi would be equal to 2 pi n, because in one rotation the angle rotated by the coin is 2 pi, so n will be equal to 30. So the coin will be performing 30 complete rotations in the time in which it will return to the ground. Now we move on the next question. In this question, you can see that there is a rectangular loop of side 4 by 2, and this is being moved away from this wire with a velocity v, constant speed v, but the direction of v is this. So this wire is carrying a steady current of 10 ampere in positive x direction, and due to the electromagnetic induction, a current of 10 microampere flows through the loop when it is at a distance of d, which is 4. The resistance of this loop is 0.1, and we have to find out the value of v. See, let us examine this problem and let us see that what is the situation. This is Vx, and Vx is root 3 V by 2, and this is Vy. Vy is V by 2. Okay, so we know that the magnetic field, let us see that there is an element like that. So the magnetic field due to this wire at this point and at this point would be same, and the EMF generated in these two wires would be equal in magnitude. As this EMF is equal in magnitude, so we will apply, let us suppose that this is a battery which has a polarity plus and minus, this is plus and minus, and these two EMF are equal. So when we will apply KVL in this loop, so this EMF will cancelled out. You can see that plus E, and this would be minus E. So the complete EMF, I can name the wires A, B, C, D. So I can say that the EMF of AB will be cancelled out by the EMF of CD, because they are equal. Okay, now we just have to find out the EMF of AD and BC. Now at AD, magnetic field is constant throughout on this wire, and B will be equal to mu naught I by 2 pi into D. This distance is D. Okay, and the component of velocity which is perpendicular to this length is V by 2. So the EMF induced in AD will be equal to mu naught I by 2 pi D. This is magnetic field B. Length is D by 2 and this is 2. And the velocity is V by 2. So EAD will be equal to mu naught I dV by, this is 8 pi D. So cancelling this D with D, you can say that it is mu naught I V by 8 pi. Okay, so this is the EMF induced in the wire AD. Now in wire BC, the only difference in AD and BC is the fact that BC is at a distance of 2D from this wire and AD is at a distance of D from this wire. So we can say that the magnetic field at BC would be, at BC, B will be equal to, magnetic field will be equal to mu naught I by 2, in fact 2 pi, this is 2D, and the EMF in BC will be equal to mu naught I by 4 pi D into length is D by 2 and velocity is again V by 2. So EMF in BC will be equal to, this is mu naught I by 16 pi into V. Now the net EMF in the wire will be mu naught IV by 16 pi. We have subtracted these two EMF. The fact due to which we have subtracted these two EMF is that they are opposite in polarity, and when we will apply KVL in the loop, then they will be cancelled, they will be subtracted. So the EMF induced in the loop is mu naught IV by 16 pi, and the current in the wire is induced due to this EMF is E by R. So mu naught IV by 16 pi R is equal to I. Now the value of induced current is 10 microampere and value of current flowing in the wire is 10. So this is 10 and this is 16 pi, and the value of resistance is 0.1 and the current is 10 microampere. This is 10 into 10 to the power minus 6. Okay. Now the value of mu is 4 pi into 10 raised to the power minus 7. So 4 pi into 10 raised to the power minus 7 into 100 V by 16 pi is equal to 10 raised to the power minus 5. So you can see that this is cancelled and pi is cancelled with pi. V will be equal to 4. So the correct answer is 4 meters per second. Now we move on the next question. In this question, you can see that there is a string of length 1 meter and its mass is 2 into 10 raised to the power minus 5 kg. This string is under the tension T and it vibrates with two successive harmonics which are 750 Hz and 1000 Hz. So the value of tension in this string would be, so we know that when the string is connected from both ends, then all the harmonics are observed in it, and therefore the difference of frequency of two consecutive harmonics would be the fundamental harmonic, and therefore we can say that the fundamental harmonic would be 250, which is the difference between 1000 and 750. So it would be equal to 1 by 2L under root T by mu. So 250 will be equal to 1 by 2. Now the L of the string is 1 and the tension is T. Mass per unit length will be this one, 2 into 10 raised to power minus 5, because length is 1. So the value of T we have to find out. So you can see that this 250 is equal to 1 upon, in fact we can square them up, 625 into 10 raised to power 2 will be equal to 1 by 4 into, this is T by 2 into 10 raised to power minus 5. Okay, so T would be equal to 625 into 8, and this would be 10 to the power 3. So you can see that 625 into 4 is equal to 2500, and into 8 is 5000. So in fact this would be minus 3, so minus 3. So it would be equal to 5 Newton. So the tension in the rope will be 5 Newton. Now we move on the next question. In this question, you can see that there is a piston which is movable and it has a small pinhole in it, and in that pinhole we have fitted a capillary tube, thin capillary tube of inner radius 0.1. There is a liquid which is inside this container below the piston, and there is some air trapped between this piston and liquid. This air is compressed isothermally to 100 V0 by 101, and V0 was its original volume. So we have to find out the height h of the capillary rise in the tube. The additional data is given in here. You can see that the pressure P inside this air can be calculated. Initial pressure was P0, which is the atmospheric pressure, and initial volume was V0. So isothermal conditions say that P0 V0 would be equal to PV. So P into V would be 100 V0 by 101. So P would be equal to 101 by 100 P0. Now you can see that, let us mark some points, that this is point A and this is point B just inside the meniscus, and this is point C and this is point D. So we know that point D has a pressure of P and point A has a pressure of P0. So at point B, as you can see that A is on the concave side of the meniscus, therefore at point B the pressure would be slightly lower than pressure at A. So pressure at B would be equal to pressure at A minus 2T by R, where this R is the radius of meniscus, and due to the fact that angle of contact is 0, it is given in the question, then therefore we can say that radius of meniscus and radius of tube will be equal. So pressure at B will be equal to P0 minus 2T by R. Now pressure at C will be equal to pressure at B plus H rho G, and pressure at C will be equal to pressure at D. So pressure at C is PA minus 2T by R. In fact, you can write it as capital R plus H rho G, and it would be equal to pressure at D, which is 101 P0 by 100. Now you can see that PA is itself equal to P0, So h rho g minus 2t by r is equal to 101 p naught by 100 minus p naught, which is 1 p naught by 100. Okay, so we have to find out h. So h would be equal to p naught by 100 plus 2t by r divided by rho g, obviously. So h is equal to p naught by 100 plus 2t by r divided by rho g. So h will be equal to p naught is 10 to the power 5 divided by 100 plus 2, and the surface tension is 75 into 10 raised to power minus 3 divided by the radius of tube is 0.1 mm. So it is 1 into 10 raised to power minus 4. Okay, and the density of the liquid is 10 raised to power 3 and G is 10. So this is 10 raised to power 3 plus this is 150 into 10 raised to power 1. So you can write it as 1.5 into 10 raised to power 3 divided by 10 raised to power 4. So h is equal to this is 5 by 2 into 10 raised to power minus 1. So h will be equal to 0.25. So h is 25 centimeters. This is in meters. So the correct answer is 25. Now we move on the next question. In this question, you can see that in a radioactive decay process, the source S1 and S2 has same activity at T is equal to 0, and at some later time activity of S1 is A1 and activity of S2 is A2. Now when S1 and S2 have just completed their third and seventh half-life respectively, so we have to find out A1 by A2. See, first of all, let us see that initially the activity of these two elements is same, and you can see that we can write it down that activity A is equal to lambda n. So initially at T is equal to 0, we can say at T is equal to 0 we can say that lambda 1 n naught 1 will be equal to lambda 2 n naught 2. So n naught 1 by n naught 2 will be equal to lambda 2 by lambda 1. Some later time at T is equal to T, their activities are A1 and A2. So A1 would be equal to lambda 1 n1 and A2 would be equal to lambda 2 n2. So we have to find out A1 by A2. So A1 by A2 would be lambda 1 by lambda 2 into n1 by n2. So A1 by A2 would be equal to this lambda 1 by lambda 2 will be equal to n naught 2 by n naught 1. So this is n naught 2 by n naught 1 and this is n1 by n2. Now you can see that we know that n1 will be equal to n naught 1 upon 2 to the power n, where n1 is this n1 is the number of half-lives it has completed, and n2 will be equal to n naught 2 upon 2 to the power n2. Okay, so n naught 1 upon n1 will be equal to 2 to the power n1, and n naught 2 upon n2 will be equal to 2 to the power n2. So you can substitute this value in equation number 1. So a1 by a2 will be equal to you can see that this is n naught 1 by n naught 1 by n1, and this is n naught 2 by n2. So n naught 2 by n2 is 2 to the power n2 divided by n naught 1 by n1 is 2 to the power n1. So a1 by a2 will be equal to 2 to the power 7 divided by 2 to the power 3. So it is 2 to the power 4, which is equal to 16. So the correct answer would be 16. Now we move on the next question. In this question, you can see that 1 mole of an ideal gas undergoes 2 different cyclic processes. This is 1 and this is 2. The PV graph is shown. Now it is given that these processes are isobaric, and this is isothermal, this is isobaric again, and this is isochoric. So we have to find out the ratio of work done in these two processes. First of all, let us see that the work done W1 would be equal to the work done in this first process, which is isobaric. So it would be 4P0 into V0. This is difference is V0 plus this work done would be isothermal work done, which is nRT ln V final by V initial. So now n is 1, RT is P0 V0. nRT you can write it down as PV. Okay, so P at this point is 4 and V is 2, so it would be 8 P0 V0 ln 2. And work done in this process would be minus 2 P0 into 3 V0, which is minus 6 P0 V0, and work done in this process would be 0. So work done W1 will be equal to 8 P0 V0 ln 2 minus 2 P0 V0. Now in second process, you can see that this is isothermal process. So and work done would be PV ln V final by V initial. So PV would be 4 P0 V0 ln 2, and in this process it would be 0, and in this process it would be minus of P0 into V0, and in this process it would be 0. So the ratio of work done would be 2. You can see that. So the correct answer is 2. Now we move on the next question. In this question, you can see that there are two identical sources of frequency 656 Hz. S1 is located at O and S2 is moving in anti-clockwise sense around S1 in a circle with a uniform speed of 4√2 in the circular path as shown in the figure. There are 3 points P, Q and R in such a way such that P and R are on the diametrically opposite ends and Q is at this point. Now there is a detector which is placed at P, and the source S1 can move along the line OP. Okay, and we have to find out the speed of sound is given as 324. So we have to find out when only sound is emitted by S2 and S2 is at Q, then frequency measured by the detector is. So when S2 is at Q, this point, then you can see that it would be having a velocity of V, and the component of this velocity would be V by √2, because this angle would be 45 degree. Okay, so we can say that this is the detector and source is moving away from the detector, so the frequency observed would be V of sound, or we can write it down as V, divided by V of sound minus V of source. So minus would be used when the source is coming towards the detector, but in this case source is moving away from the detector, so it would be plus V by √2, and this V is V0, or we can say as VS1 or S2. So F dash into F. So F dash would be 324 into F upon V plus V by root 2, which is 324, plus this is V by root 2 is 4. So you can see that F dash is equal to 324 upon 328 into 656. So this is 2 and it would be 648. So the correct answer of this one is 648. Now we move on the next part of this question. In this part, you can see that again the same situation is given in the question, and you can see that both are emitting the sound, and S2 is situated at R and S1 is approaching the detector with the speed of 4. So the beat frequency measured by the detector. So the frequency registered by the detector due to emitted by the source S2. So let us write it down as FS2. So S2 is at this point and it is going like that. So there is no relative motion of S2 and the detector, therefore the frequency observed by the detector would be true frequency. And due to S1, as S1 is moving towards the detector with 4, so frequency due to S1 would be equal to 324 upon 324 minus 4 into F. So Fs1 would be equal to 324 upon 320 into F. So the beat frequency F beat would be equal to Fs1 minus Fs2. So F beat would be equal to F is common, 324 by 320 minus 1. So F beat is equal to F into, this is 4 upon 320. So F is 656, I guess, yes, and this is 4 divided by 320. So it would be approximately 8.2. So the correct answer of this one is 8.2. Now we move on the next question. In this question, you can see that there is a blast furnace, or there is a furnace in which air is entering from this inlet at a pressure of Pa and density of air is rho A and temperature is Ta, and this air is heated in the furnace to the pressure, to the density rho, and it is heated at constant pressure P. The diameter and the height of this furnace is given, and the temperature, we have to find out the in fact temperature is 360, which is the final temperature, and the air which is entering the furnace is having the temperature of 300. Now the heated air is moving up and it is leaving the chimney from this end. now let us we have to find out the rate at which the mass of air would leave from this end. So let us first of all find out the density of heated chimney. We know that this is an isobaric process, and in isobaric process we know that the equation of isobaric process is V1 by T1 is equal to V2 by T2. And we also know that temperature is inversely, in fact volume is inversely proportional to density. So we can say that rho 1 T1 will be equal to rho 2 T2. Now rho 1 is 1.2 and T1 is 300, and rho 2 is unknown. Let us suppose that rho 2 is rho, and T2 is 360. So rho, you can see that it would be 1. So the heated air has a density of 1 kilogram per meter cube. Now first of all, let us see that pressure at this top surface is P, let us assume, and pressure at here would be Pa, we know. So you can see that outside the chimney the air is at a density of rho A. So we can write down that PA would be equal to P plus rho A into G into H plus H, which is 10. H plus H is 10 because H is 9, this H is 9 and this H is 1. Now let us apply the Bernoulli theorem between 1 and this point 2. So P1, the pressure at 1 is P plus half rho V square. Now you should be careful while writing the density. You should know that the air which is leaving out the chimney has a density, expanded density, which is rho, which is 1. And this point is also above this point by a height of H plus H. So the density of air inside this complete chimney and furnace is rho, which is the heated air. So rho G H plus H is again 10, and this is equal to PA, where PA is the pressure at this point. Now we have assumed that at this point velocity is negligible because diameter is quite large as compared to this diameter. So P is equal to this. P is equal to PA minus rho A G into 10. So PA minus 10 rho A G plus half rho V square plus 10 rho G is equal to PA. So you can see that half rho V square is equal to 10 G common, and this is rho A minus rho. So half rho is 1, V square is equal to 100 into, this is 1.2 minus 1, which is 0.2. So V will be equal to under root of 40. Okay, and the mass density. Now we have to find out the mass density. So we know that dm by dt, in fact mass rate of flow. So dm by dt is equal to d by dt. In fact, we can write down dm as rho dv, and dv is the volume of air leaving out. So rho dv would be rho into a into dx upon dt. Dx upon dt is v. So this is rho AV. So this would be equal to, rho is 1, area is pi d square by 4, and V is root 40. So this would be equal to pi by 4 into d, where d, small d, you can see that small d is 0.1. So this is 10 to the power minus 2 into root 40. So it would be approximately 49.1 something. So this would be the correct answer. Now we move on the next question. Now in this question, this is the B part of that question. In this question, this chimney is closed from the top, and due to the closed chimney and due to the difference of density inside and outside the chimney, a difference of pressure is created at this point 1, which is just outside the chimney, and at this point 2, which is just inside the chimney. So let us first of all, we have to find out this pressure difference. So let us first of all see that pressure here it is open and here pressure is PA. So the pressure at PA will be equal to P1 plus rho A into G into 10, because outside air has a density of rho A. And pressure at this point inside the chimney is also PA. So PA is also equal to P2 plus rho inside the chimney and G into 10. Okay, so P1 plus rho A G into 10 is equal to P2 plus rho G into 10. So you can see that rho A is greater than rho. So P2 minus P1 is delta P, and it is equal to rho A minus rho G into 10. and rho A minus rho is 0.2, G is 10, and it is 10. So it is equal to 20 Newton per meter square. So the correct answer of this one is 20. Now this is the last question of this paper, and it was quite a um easy physics paper in this year of JEE Advance. And this question, last paragraph, was controversial, and I guess this is the final correct answer of this questions, and therefore I was waiting for JEE to release the correct answer key. So this was the solutions, detailed solutions of JEE Advanced 2023. Thank you.